You. Quick question. What happens when force is applied on a mass? If you said it changes its state of motion or its direction or simply speeds up, if it's already in motion, then you're right. Now, another quick question. You. Imagine yourself pushing away a dish you don't like and pushing your own car. Which one is more harder? What kind of profession is this, Professor? Pushing the car is more harder, of course. And why? Because it's heavier. It has more mass. Now, remember the first question I asked you. When a force is applied, the object changes its state of motion, and when it does, we term this function as acceleration. Now, you've looked at three things: force, mass, and acceleration. Now, putting these three terms together in an equation is nothing but Newton's second law of motion. This law connects these three terms to put it in a mathematical form to form an equation. The equation is nothing but net force equals mass times acceleration. The heavier the mass, the more force needs to be applied. The more force applied, the more accelerated the body becomes. Since acceleration is more when the net force is more, and less when the net force is less, we can put it in this way. Acceleration is directly proportional to force, right? Since acceleration is more when mass is less, and is less when the mass is more, we can put it in the form: acceleration is inversely proportional to mass. Cutting it in. Now, since the unit of mass equals kilograms and acceleration equals meters per second square, the unit of force is the product of these two, kg meter per second square, or simply, to honor the great scientist, Newton. Now, I'll ask you all a few questions, and your answer should be quick. Mr. Wild, if an object of mass 10 kilograms is moving with an acceleration of 9.8 meter per second square, then what is the force? Quick! Stop laughing, you all!
The answer is 98 Newton, Professor.
Good. If a net force of 80 Newton is applied on a body of mass 2 kilograms, then the acceleration is?
It's 9 meter per second square, Professor.
Bravo. Now, imagine a 1 kilogram mass hung by a string with tension 5 Newton with the acceleration downward. Now, this object is also pulled down by a gravitational force of 10 Newton. Now, calculate the acceleration of the mass. Okay, I understand. This was quite tough. Now, whenever an object is hung by a light string, there's always a force away from the object in the string. This force is known as tension. Now, apart from tension, there are also other forces like gravitational force that are pulling this object downwards. Now, in such a problem like this, all you have to do is first find out the direction of these forces. If the direction if the direction of both these forces are the same, just add these two forces. If they're in the different direction, just subtract these two forces. Here, the net force is 10 Newton minus 5 Newton, which gives 5 Newton. This is nothing but your net force. Now, put it in the formula: acceleration equals net force by mass. Here, the net force is 5 Newton, and the mass is 1 kilogram. Then the acceleration is 5 meter per second square. Now, good old Newton's second law is also called the law of conservation of momentum.
Professor, what is momentum?
Momentum is basically mass of an object times its velocity. Two important factors in the motion of any object. Momentum is denoted by the letter P. The formula is mass times its velocity. You know that force, mass into acceleration, right? Now, Acceleration can also be written as change in velocity by time. Now take the initial velocity as u, the final velocity as v, and acceleration is basically v minus u by t. So we can write force as mass times change in velocity by time. Am I right? Now change the velocity by time is v minus u by t. So mass times v minus u by t is mv minus mu by t. Now momentum is mass times velocity. So mv minus mu can be written as change in momentum. So we can also write force as change in momentum by time. This is the reason why Newton's second law is also called by the name the law of conservation of momentum. Now, the concept is almost over, so it's quiz time. I'm gonna ask you a hard question, and if you can solve it, you have practically understood this concept clearly. A cricketer caught a ball of mass 150 grams moving with 20 meter per second velocity. What is the force exerted by the ball on the hand of the cricketer if the process is completed in 0.1 seconds? Anyone got the answer?
I got it! Force is momentum by time, and momentum is nothing but mass times velocity. So, force can be written as mass times velocity by time. Here, the mass is 150 grams, which can be written as 0.15 kilograms, and the velocity is 20 meter per second, and the time is 0.1 seconds. So, substituting it in the equation will give force equals 0.15 kg times 20 meter per second by 0.1 second. 0.15 times 20 is 3 meter per second. 1 seconds. Now 3.3 by 0.1 is 30. 30 kg meter per second squared, which is nothing but 30 Newton. The force is 30 Newton.
Was brilliant. Good job. You're really Oh, it's the bell. Wait. No, the bell doesn't dismiss you. I do. Don't forget to like, share, and subscribe. And leave your doubts in the comment section below. I'll be sure to solve them. Okay. Class dismissed. Ta-da!